Hi guys, in my last video I showed you how I add a torch high controller or THC on my CNC Plasma cutter here, and it seemed to work well on some kind of like medium thick sheet metal like this one, about 1.5mm thick. But when I tried to cut some kind of like metal off on this thin piece, it didn't work. The piece kind of worked a lot, and the THC system supposedly it should work on this type of situation. But I tried so many times to adjust all the parameters on the controller, and in the end I kind of give up on the THC. Sometimes the torch kind of like crash into the piece, or sometimes the THC just leave the torch too high and it didn't cut the piece. So now I have to think about a solution that I can still cut this thin piece of metal without the THC system, but the torch can still follow the warping of the piece, and it also had to maintain the constant high when cutting. The thing that I can think of is very similar to this system. This is the original torch that came with my plasma cutter. It have a ring here, just kind of the spacer for manual cutting. But with this ring, I cannot really adjust the torch height when cutting, and also that the end of the ring here might get caught in a hole when it's dragged around on surface of the sheet metal. So I would have to make my own ring that I can attach to this torch, so it can do two things. It can like glide on this surface very smoothly, and also it can be attached to the torch very sturdily, so it can maintain the torch height constantly when cutting. And also, you will be able to adjust the torch height accordingly, following the thickness of the sheet metal, the ampage, the air pressure, and also your plasma cutter. So let me just try to design something and show you how I'm going to make it. I will try to mill the ring out of this piece of aluminum. It's 2.2mm thick. Now I have the ring milled. I will have to make a setup to put it into a conic shape. I made these two pieces to shape the ring in the conic shape. So I have the positive mode and negative mode. I'm just going to put the ring in here like this and force it into the hole here, and then put this one on top and press it down. Hopefully that the plywood will be hard enough to shape it. If not, I will try to use my hammer to shape it into the conic shape that I need. It seems to be working a little bit with my drill press, but I will have to use the hammer to force it into shape. As you can see, after forcing with the hammer, I have here a conic ring. The angle here is about 20 degrees, and the reason I made it conic because when the ring is gliding like this on the surface, if it get into the bump like this, it will just bump up like this because of the angle. So that's why. Okay, so now I'm just going to use my plier to bend this upward like this. Like this. And then bend this sideways. Roughly 90 degrees. So I'm just going to do it for all of the arms here. The shielding ring will look like this. And then I might need to round up the edge here a little bit so it can glide a bit smoother. And then I will make another ring to fix this ring on the torch. The bit just broke in the middle of the tool path here. I think I went a bit too deep on the step down. So let me just rerun this with the step down a bit smaller. Now I only need to drill a hole through here so I can tighten it on the torch. I'm just going to use the 6mm drill bit. Now let me show you how I put the whole shielding setup together. I will need 4 of the M6 bolts. Here I use 30mm length. You can use longer if you want. Now all the bolts are fixed on this ring. If you need more space between this one and this one, you can use longer bolts and put more nuts in here. It depends on your torch. For mine, this will be fine. So I just slide the bolts in the slot here like this. It looks centered already here, but if you need to adjust a little bit, the slot here will give you some range. Here how it looks like in the end. Let me show you how I install this on the machine. Now on my Z-axis, as you can see that I have a spring here to push the torch setup down, and I also have this limit switch for the floating Z-axis. So I will uninstall this and this. Now I have the spring and also the limit switch uninstalled. My torch can slide up until here, so it's about 3 centimeters of range. I think that wouldn't be more than enough for any type of warping. Now I only need to attach this ring to the shielding cap of the torch here, and the reason just I want to install it on the shielding cap because later on if I want to change the consumable like the nozzle tip here and also the electrode inside, I only need to uninstall the whole thing by twisting this ring so the shielding cap will come off with it. So I will need to uninstall this ring separately and readjust the height every time I change the consumable, so that will be more convenient. Next step, I just going to push this ring in here. Now before tightening this ring, you will need to adjust the cutting height. To do that, you only need to adjust the distance between the nozzle here to the edge of the ring like this. So for me, I will try to keep it about like 1.5 millimeter. Yeah, I will try like this first. So I'm just going to tighten the ring here so it doesn't slip up and down. Now I have this setup ready to run, so let me just do a quick test to see how it works. I have this piece of sheet metal, just I bent it a little bit so it's kind of wavy. So I'm just going to try to cut a slot here. First of all, I'm just going to run a G-code without turn on the torch to see how it follows the curve. And for the second test, I will try to actually cut the slot. And to adjust the torch height, you should go to the lowest place on the piece of sheet metal here and lower the torch until the tip of the shield here. That's the piece of sheet metal, and it shouldn't go too far down, because if the shield here go into the hole and it's too low, the edge here will get caught and it won't be able to move. And of course you shouldn't leave it too high because the tip of the torch will be too far away and it won't cut correctly. So now I just lower it down. Now I'm just going to try to run the G code to see if we go like around and follow the curve here. As you can see that the torch moving up and down correctly following the curve here, and sometimes it even pushes the piece down a little bit, but that shouldn't be a problem because only the shield touches a piece of sheet metal, not the tip of the torch. Now I'm just going to try to actually cut the slot out. Two things I forgot to mention. First is that the tip of the shield here will scratch on the piece of sheet metal, so it will drag the piece around if you don't secure it tightly. Second is that in sheet cam, you should choose the post processor is match 3 no Z, just mean no Z axis. So it's just going to do it like this without adjusting the Z axis. And also in match 3, I just deactivate the limit switch. As you can see here, I have the piece cut out correctly. Now I will try to make a metal ore on this thin piece of sheet metal. It is less than 1 millimeter thick, so it will warp a lot, and I have to clamp it down so it doesn't move. And for the cutting parameters, I use 10 and 2 meter per minute speed rate. And the reason that I want to go slow because I want to cut precisely. That's why I have to reduce the ampage to cut cleanly. If I want to increase the ampage, I will have to cut like faster, and that will create a lot of vibration and imprecision in cutting. So now let me just show you again how I'm going to set up this torch. I'm just going to lower the torch until it touches this plate and it cannot go down anymore. Okay, like this. And now I just go to the corner and set X0 and Y0. And that's it. Let's see how it cuts. I almost did it, as you can see here, but in the end my consumable burned out, so I couldn't cut the outline, as you can see. And I have another problem here, that when the cutting get long, everything get hot, so this ring of wood start to get some cracking here, and it couldn't hold on tight on the torch anymore. And also that this piece is made of wood, so I have some kind of fire hazard right here. I think that this piece should be made of aluminum or something like that, so let me just try to do that first and then try again. I got this piece of aluminum from the hardware store for only $6, and it is 3 by 8 of an inch thick, so it is really cheap for the purpose that I'm using it for. The milling of the ring is done. It went overall really smooth. At the end I think that I went a bit too fast on the 2D contour, and I got lucky that my bit only broke like right at the end of the two pass, so the piece still like mill out correctly. So now I'm just going to clean it up and show you the next step. Now I'm just going to make a hole all the way through here using a 3.5mm drill bit. Next step, on this upper half, I'm just going to make the hole bigger using a 4.5mm bit. Now I'm just going to thread this smaller hole using a 4mm tab. That's it, this ring is ready, so now let me just mount the whole setup on the machine. I have the setup installed here, and last time when I cut this piece, the outline wasn't cut correctly. It actually wasn't because of my consumable burnt out. The real reason is just my air compressor was off, and so in the end there wasn't enough air like blow out to cut this piece. That was really a newbie mistake, but I never claimed myself expert in this, so that's probably normal. But this time I remember to turn on my air compressor before I start cutting. So now I will recut this metal on this thin piece of sheet metal. It is even thinner than this one. It is 0.5mm, so you're going to warp like really a lot. And if you have question about this wire just I have here, I'm just testing a solution for a really annoying problem just a lot of people are having with the CNC Plasma cutter, so I will explain in a lot more details in my next video. This time it went really smoothly, even though this piece is really whoopy right now, but the torch followed the curve very nicely and every cut worked clean. I don't think that you can ask for better cutting quality on any plasma cutter. Now this piece only needs some sanding and polishing and it will be beautiful. Let me just summarize quickly about the setup that I have right now to control the torch heart. First of all, this setup is really cheap and easy to make, especially if you have a CNC milling machine like I do, compared to the electrical THC system that you have to buy for a lot of money, like at least $200. And then you also have all type of wiring and setting up. This setup doesn't require any type of wiring modification to your CNC machine or plasma cutter. It can work with any type of torch. You will only need to make the inner diameter of this setup adapt to the diameter of the torch, and that's it. So I think that I will have to sell my THC system to someone who doesn't watch this video.